Hello and welcome to my next video. I'm Better Programming with Munir. In today's lecture, I will talk about multitasking through ESP32. So I have this board. So it's DevKit version 4P32 provides multi-core. So it has this chip has two cores. So we can how we can utilize the multitasking or have how we can create freeRTOS task in this, and then I will tell you how you can code in C++ using the esp-idf, and how you can need to link the freeRTOS task in the CPP files. So let's start. So here is I have created a project named multitasking. So I will be putting this on my GitHub repo so you can go through it. So here I have a very simple program that is printing. So now since we need to create multitasking, so let me create some tasks. For example, void task one, just loop through it using the same thing. We are just printing from task one. Okay. Next, we create another task, task two, and we print from task two. So if for this one, we put a delay for 2 seconds, and for this one, we create 1 second. So you can see multiple creation. So if you want to create these, so we need the handle, task handle, task one handle. Similarly for task two handle, let initialize them with null. You can just use x task create lab API. You can see first you need to pass the function task1, give it a name as task1. You can use this name later for the different debugging purposes and statistics. So we provide stack depth. You can calculate according to your requirements. So this is provided in bytes. So then we need to pass it a parameter. So since we are not going to pass any parameter, so we will put it null. And we will give priority to 5. You can define this in a variable as well. Next, task 1 handle cndle. Okay, so we copy it and create the second task. Now we build it and flash it. So we can go and select our microcontroller. I have connected with the COM port 4, I think. Now we build it and flash it. So we can go and select our microcontroller. I have connected with the COM port 4, I think. Let me build it and flash it. Okay, so you can see it's printing from task 1 2 times, then task 2 and main loop. So now move to the CPP file, how we can create CPP. So just rename it to CPP, and what other difference would be extend keyword, and you will see other differences as well. So here you need to change it to CPP. Now you will see some errors, I think. Here you can see invalid from void pointer. So same thing we are converting to CPP and it's throwing error. So first, what is the error? So you can see invalid conversion from void pointer argument to task function. So the error is basically it is asking for a function pointer which is of type I think void pointer. We just need to provide the parameter. Same here with this one. I am doing and showing you the error so that if you ever come to these kind of errors, you can easily handle these. Okay, so now we need to pass the address of this pointer. Either you can make it pointer or you just pass its their addresses. So now the build is successful. So you have seen that if we are going to convert it to CPP, we need to apply the function pointer of matching parameters. Now let's create a folder in the components and we create a class called tasks. And then we add some files into it, task.cpp and then task.hpp. I am adding extension HPP just to differentiate from C files to CPP files. So here we can add task.cpp. Okay, so now we create a class. So let me copy all the libraries from here in main. Okay, also include string.h, so we would be needing that. We create a class task and we add some function. So what I need from my class, whenever the object is created, it should start a new task. So I will put everything on the constructor and destructor. So I will also pass a name. So task name. So I can print which task is basically printing this thing. And a destructor to clean up the code at the end. Then I will keep all other my stuff as private. For to create a new task, we need at least three functions. Things and let me copy that. I have to create a task, I have to start a task, run a task, and then I can delete a task. So why the this function is kept as static just to give the class that this function already exists and it has a memory space. So let move these tasks into main cpp main. Here hash include task.hpp. Then we can go with all the stuff. Uh, Tname, and then we have a destructor as well. Just to clean up the code, we add super suffix here. We need to remove static from here. Okay, so now what I am going to do is I will put a check if t name is null. I will esp log error. not create task as name is invalid. Okay, if it is okay, then I will go and create the task. First, assign the task name, create new. You can do whatever way you want. I am just demonstrating how you can basically use these stuff. Rename, and then you can need to strcpy strcpy as a C function, so you can directly use this into this one. Task name, then rename the source. Here you go, and then you need to call a function create task. Now what we are going to do here is, if task name is not null, we need to delete it to free up the memory. And I also assign null to avoid dangling pointers or while pointers, and then call delete task. So here we just need to create x task create, just like we did. So here we are passing start task, task class, the name, and then we need to pass the stack size, and then here we will pass this parameter to avoid any kind of error or misuse. So why this is actually the trick that you need to use. So task handle, and here I have to just create a task pointer and typecast the parameters here, and then I can call the processing function run task. These steps are needed to create a task freeRTOS task in CPP files. You would need at least you can do in two function as well if you are calling this x task create directly into your main function. Then delete function, if task handle, then we task delete, and put it to null as well. I hope we are good to go. Okay, now update the main file. So let me delete these tasks and just include task.h file. And here we are going to create some task. Task 1, let's give it a name, task 1. Task 2 and task 3. Okay, task 2, and create a task 3 with null, so we will verify our condition. Okay, driver is not available, so let me give it into requires. In last in our previous videos, I have mentioned that how you can link your libraries. So since we are using GPIO here and it is giving error, so if you click on it and you will open the directory. So here you can see it is available in components driver include driver gpi.h. So the top folder name is actually the linking of class name. So here we need to just pass on our driver like available. So let me give it into requires. In last in our previous videos, I have mentioned that how you can link your libraries. So since we are using GPIO here and it is giving error, so if you click on it and you will open the directory. So here you can see it is available in components driver include driver gpi.h. So the top folder name is actually the linking of class name. So here we need to just pass on our driver like okay, our build is successful. It's flashing now. So here you can see it's printing from task 1, task 2 and then loop task simultaneously. So that's it from my side. If you have any questions, please feel free to put in the comment section. Thank you.